In this question, it is mentioned that a waiter is carrying a tray and the person is accelerating to the right hand side as shown in this figure. And we are supposed to draw the free body diagram. Now, how do we do this? If we analyze only at the tray, so we need to figure out which forces are acting only on the tray. So, one of the forces is always there, which is the weight of the tray, which always acts downwards. Let me draw that in the image. The weight of the tray, W, which is equal to mg, always will act downwards. Now think, is there any force apart from the weight? Yes, it is. So the tray is held by the person, which means the tray is in contact with the hands of the person. Hence, the tray will feel a contact force. And if you remember, the direction of normal reaction or contact force is always perpendicular to the contact surface. So imagine if this is the surface, so you draw a perpendicular to that particular surface. But in this case, if you observe carefully, look at the diagram, the tray is bent at an angle. So the tray is at an angle. So consider this is your tray. So the contact force will go perpendicular in this particular direction. So in the diagram, let me draw. We draw the direction of normal reaction perpendicular to the tray. Let me write that down. This is 90 degrees. And this is called the normal reaction or the contact force. Apart from these two forces, there is no other force acting on the tray. Now let's look at the options. In option A and B, they have shown three forces, which is not correct. As we saw, there are only two forces acting on the tray. Hence, option A and option B can be discarded. Now, this is where it gets a little tricky because if you look at option C and option D, they look pretty similar. In both C and D, we have a downward arrow, which is the weight of the object. That is correct. But what about the normal reaction? In option C, the arrow length of normal reaction is smaller as compared to the arrow in D. So, which option do we pick? Now, this is where we go back to the basics, Newton's second law, which is F net is equal to ma. Hence, the direction of acceleration is the same direction as the net force. So, let's read this. In the question, it is mentioned that the acceleration is towards the right hand side. We saw it is clearly given the tray is accelerating to the right hand side. Now, if you remember the Newton's second law, which states that F net is equal to m into a. Hence, the direction of the force is the same as the direction of acceleration. Since the acceleration is towards the right side, which means the net force is also towards the right side. In the next statement, I have mentioned something about the parallelogram law. So let us try to recall what was the parallelogram law itself. Imagine if you are having any two vectors. So how do you find the direction of the resultant force? That is done by the parallelogram law. So let us revise the law itself first. So imagine we have two vectors. Let us draw. A is one vector and B is another vector. And we have to find the direction of the resultant. So the trick here is step one, complete a parallelogram. So make a parallelogram using the two sides of the vectors. And once the parallelogram is drawn, then we draw the diagonal like this. Now, this diagonal gives you the direction of the resultant force. So going back to the question, the answer is either C or D. We need to identify an option where the net force is towards the right hand side. So, how do we do that? All we need to do is just draw a parallelogram using the vectors involved. So, if you look at option C as well as option D, let me show you the diagrams. So, have a look. In option C, if we draw the parallelogram, so this green dotted lines complete the parallelogram, and then the red arrow is the diagonal. So the resultant of these two forces, the resultant of these two black forces is the red arrow, which means in option C, the net force is in this particular direction. But remember, we needed a situation where the net force should be right, which is incidentally true for option D. Look at the two black arrows, and then if we completely make a parallelogram and then draw the diagonal, we can see the arrow, the red arrow is pointing towards the right hand side. We can deduce that the net force is towards the right hand side, and hence we can say D is the right answer for this particular question.